Everything you need to construct your Rascal robot is included in the toolbox supplied. This is the user equipment included in the Rascal construction set. 5 and 2.5mm hex keys, 2 0-point Phillips screwdrivers with blunted tips for safety, and a pair of safety glasses. These are the pieces that go together to form the base and pivot post assembly of the Rascal kit. This is the base, and the pivot post will eventually fit here. We will deal with the pivot post first. Taking the 5mm hex key, use it to remove the socket head cap screw from the bottom of the assembly. Once the socket head screw is removed, the pivot post will split into two. The bottom half, called the riser, can be put aside for the moment. The next job is to remove the socket head screw from the top of the pivot post. Once removed, this too can be put aside for the time being. This small hex screw can be used to tune pivot post damping once the robot is operational. This raised area around the screw hole is used to locate the aluminium link that will be attached to the top of the pivot post. In this recess here are splines and a captive screw, which helps locate and attach the pivot post to the servo. Between the protrusions, or dogs, on the base of the component is a radial groove called the pivot post alignment mark. We will use this to set up the pivot post servo in a moment. This is one of 6 servos that come with the Rascal set. The servo can connect to the supplied aluminium links as well as other parts of the set. The links themselves come in sizes of 2, 3, 4, 5 and 6. Right now we will be using the 6 link. When you first receive the servos, the boss around each output shaft will be very slightly oversized. You'll reduce the boss diameter to a precise fit to all link holes by working each servo boss into the end of a 6 link, as shown here. We will take a moment to look at a few different ways that the servo can be attached to a link. The servo fits smoothly between the sides of the link. The boss around the output shaft helps guide the servo into the correct position. The servo will also fit anywhere along the link when correctly aligned with a hole. The servo can also be mounted on the end of the link, like this. By running the servo cable through the second hole from the end of the link, the output shaft can be used in a lower position. Or the servo can even be mounted under the link with a clamp. As with other servo mountings, motion is around the output axis. Let us begin the process of installing the pivot servo. First, take a 6 link and fit the servo to the end, with the output shaft in the last hole. Next, a 2 link is added to the back of the servo. This 2 link helps improve load distribution and servo protection when the clamp is fitted. Then take one of the molded nylon narrow servo clamps. The clamp has 2 small dogs or protrusions to hold its position on the link. Slide the clamp on, making sure the metal part of the clamp is on the shaft side of the servo. Usually you can orient the narrow clamp either up or down, but for the pivot post assembly the metal bar must be by the output shaft. Using the screwdriver, tighten up the clamp. When tightened correctly, the metal bar should be somewhat bent. Now is time to attach the servo and link to the pivot post. Carefully line up the splines on the shaft with those inside the pivot post. The boss around the screw hole acts as a guide and will line up with the hole on the link. Next up, take the short socket head screw and its washer and loosely fit them using the 5mm hex key. Fitting it loosely will allow adjustment of the splines, as shown in a moment. The next stage of the build is to align the pivot post assembly with the servo, using the alignment mark on the underside as a guide. Carefully pop the servo shaft out of the top of the pivot post. The alignment mark on the pivot post should be rotated until in line with the 6-link. The servo shaft can then be pushed back into the pivot post. Then fit the pivot post to the base plate with the link extending out from the base like this. This is the center position. Rotate the post to find the extent of the servo swing. We can see that it ends here. To increase the swing, pop the servo shaft out of the post and rotate the entire assembly, making sure the dogs stay engaged with the base plate. The swing of the servo needs to extend just over 90 degrees in each direction from center. You can keep adjusting the swing until you achieve an even amount of travel in both directions. Once done, return the post to the center position and remove from the base plate. You can see that the alignment mark is in the same central position, now indicating the center point of the servo swing. Using the 5mm hex key, tighten the small socket head screw fully. This is very important for robot stability. Then take the screwdriver and carefully locate and wind the captive screw into the servo. Take care not to force it too tight, as you could cause wear to the servo or pivot post. Back the screw off a quarter turn. We will now begin the final assembly of the base plate and pivot post. Here you can see a recessed area, which is where the larger socket head screw will sit. Take the riser and large socket head screw, which we put aside earlier. The riser has the same pattern of dogs on the underside and fits into the base plate. Then remove the washer from the screw, as it is not used in this application. Thread the screw from the underneath of the base plate up through the center of the riser. Then take the completed upper pivot post and servo assembly. Fit it onto the top of the riser, making sure you line it up at the center point where you removed it during the earlier servo alignment. Wind in the socket head screw a few turns with your fingers, then use the 5mm hex key to tighten the screw fully. The base and pivot post assembly is now complete. We will now attach the elbow servo and link to our arm. Start by putting a narrow clamp onto the 6-link. Follow this with a servo, its output shaft pointing up. Carefully adjust the servo until it is flush with the end of the 6-link. Add a 2-link to the top of the servo to act as a bearing surface, then pull the clamp back over the top of everything. Make sure the 2 dogs on the bottom of the clamp align with the 6-link correctly, and then tighten the clamp up. Tighten the clamp as before, so the metal bar is just slightly bent. We will take a moment to discuss preparing a link for fitting to a servo. This is done by fitting together the link, a link washer and a link horn. First, take the link horn and drop it into the link above the hole you want the servo to attach to. Using your fingers, carefully line the link horn up with the hole and press down firmly. The mouldings on the underside of the horn should protrude through the link. Here's an example of how not to fit the link horn. If you try and force the part into the link without dropping it, you will struggle to fit the part correctly. Always drop the horn in and adjust lightly with your fingers. After fitting the link horn, clip on the link washer. The link washer provides the bearing surface for the joint with the servo. The three pieces should fit together with no spaces. This assembly forms the most common joint used in Rascal robots. We will now add another 6-link prepared with a link horn to the second servo. Take care to align the splines correctly when fitting the link. Forcing it may cause wear to the servo output shaft. As before, we need to adjust the link for even side-to-side travel. Check where the servo swing ends and adjust the link until it is slightly more than 90 degrees from center. Now insert a servo screw and tighten. The servo screws are either supplied fitted in the servo output shaft or are found in separate packaging. Tighten the screw fully. Only if the joint seems to bind should you back it off slightly. The elbow servo and link is complete. Here we will detail attaching the shoulder and wrist assemblies. Servo 3, the shoulder, will mount under the 6-link we added last, like this. First, however, we will attach a 2-link to act as a bearing surface and also as a position guide. We will hold this servo in place with a wide clamp. First, undo one of the wing nuts and pass one leg of the clamp through the third hole of the link. Replace the bar on the clamp and hand tighten the wing nuts. The 2-link should be butted up against the 6-link, and the servo should be flush with the end of the 6-link also. Tighten the wing nuts as before, until the metal bar is slightly bent. A 4-link will now be added to the shoulder servo, with the swing divided to be a little more down than up, as the gripper will be working more on the table than in the air. Prepare a 4-link with link horn and washer as before and attach it to the output shaft of the servo. Align the servo swing with more down travel than up. Then wind in the servo screw as with the previous joint. The assembly of the shoulder servo and link is now complete. The 4th, or wrist servo, fits into the 4-link with the output shaft through the end hole. First, take a narrow clamp and slide it on, with the plastic end on the same side as the output shaft. Take the servo and place the output shaft through the first hole. Generally, we would suggest using a second 2-link on the back of this servo to aid in load distribution and create a stronger robot. In this case, we forgot, and you will forget sometimes too. Pull the clamp over the servo and tighten until the bar is slightly curved. Once you've attached the servo, prepare a 3-link in the usual way. Carefully fit the link onto the servo and align with the swing mostly downward. Screw in the servo screw as with previous joints, loosening slightly only if the joint binds. The 4th servo and link are complete. Before we add the gripper component, why not exercise what you have created so far to see what its reach or envelope is. Here we have the gripper without its 2 servo motors. You can see that it has 2 parallel fingers that we can slide together and apart. The first servo is used to twist the wrist 90 degrees in each direction. Carefully push the servo output shaft into the splined hole on the base of the gripper. The servo should have just over 90 degrees of movement in each direction, so realign the gripper if needed. To completely attach the servo to the gripper, first open the fingers. Then take a servo screw and place it in the recessed hole inside the gripper. Thread the screwdriver through the hole between the fingers and tighten the screw. You do not need to back this screw off as it does not adjust any bearing pressure. We now need to add the final servo, which will allow the fingers to open and close. The servo mounts into the guide channel on the gripper, the output shaft fitting into the splines in this recess. Open the fingers slightly and carefully push the servo in. Once fitted, we need to align the servo once more. As you can see, the servo's movement ends before the fingers close. To adjust this, remove the servo from the gripper when the servo is at the end of its movement. Close the gripper and reattach the servo. You should now have full movement of the fingers. Finally, wind a servo screw all the way in to complete the assembly of the gripper. Now we will attach the completed gripper component to the arm assembly. Fit the servo into the end of the 3-link with the output shaft pointing out, as can be seen here. Make sure the end of the servo is flush with the end of the link. Then take a narrow clamp and slide it over the link and gripper. The dogs on the underside of the clamp will fit into the 3-link as usual. Wind in the screws until the metal bar is slightly bent. The final part of assembly is to dress the wires running from the servos to the controller, using the supplied twist ties and spiral wraps. The wires run over the back of the robot and off of the pivot post. You will notice that plenty of slack wire has been left to allow the gripper to twist and open. If we didn't dress the wires, they could snag and impede the robot's movement. Once the wires are dressed, this rascal robot is complete. Why not take a moment to cycle the robot so as to get an idea of its capabilities before the next step, where you will begin programming.